must be negative 3 over 5. Okay, where I'm putting my, this is supposed to be negative 3 over 5. But the result will be correct. It's true. In a similar manner, when lambda is equal to 0.92, I will do exactly the same. Making the substitution also in this matrix 0.95 minus 0.92 and same y 0.97 minus 0.92. So I will have the matrix as you can see. Now I can multiply the first row negative and add on the last row, they will eliminate each other. Then dividing in 0.23, I will end up having 1 and 1. I will move this back to the other side, so I will have V1 equal to negative V2. And that's the eigenspace, the span of the eigenspace, eigenvector 2, which is negative 1 and 1. Now I can find the B matrix, where the first column in the first vector and the second column in the second vector. That's the B matrix. My diagonal matrix, it's gonna be the diagonal matrix with the eigenvalues on the principal diagonal. So here we go. That's the main matrix, which is the A matrix. That's the B matrix. That's the diagonal matrix. That's the inverse. Okay? So instead of dealing with A to the power of K, now it's going to be a very easy task for us. Okay, once more, A can be expressed by these three matrices. Now we can find A to the power of T, so it's not a big deal. All I have to do is to just make the substitution. So it's going to be 1 to the power of T, 0.92 to the power of T. So I can get the population after 10 years, after 15 years, and so on. That's going to be the result of the substitution, of the multiplication between them. Okay, how it's going to be on the long run after 100 years, after 60 years, after 70 years? As you can see, those numbers has the number of the population in suburbans will increase till certain value, and the change will be just neglectable, and the same for the city. So this is why we call it the city state. And it may happen at certain period of time, but it will take time. So I can simply, if I want to speculate what it's gonna be, I can get the limit of t tends to infinity. And now I can find the values. So I can simply use this relation, limit t tends to infinity, for the value of x sub t, which is a to the power of t times x. Am I right? So once more, I will use the limits. So if we get back to our model, now I have lambda 1, which is, this is the values, and already we are done from this. That's the A matrix. Instead of dealing with this matrix, I will be dealing with those guys. So if you put limit t tends to infinity on this form, it's very easy to evaluate the limit. Why it's very easy to evaluate the limit? Can you tell me? Because if you take t tends to infinity, you are correct. It's going to be 1 multiplied in itself for plenty of times. So it will remain 1. But that's a fraction, which is less than 1. Each time you multiply it in itself, the value will decrease. So it will decrease till it reaches 0. Okay? So once more, if you take the limit, as I told you, for these three matrices, which is B, D, B minus 1 times x, that's going to be the result. That's the main matrix. It's not going to affect, doesn't have t even. This guy, 1 will remain 1, and the 0.92 will be 0. But the inverse of that matrix we already evaluated. Am I right? So that's the speculation after t tends to infinity. So after changing along the time and the aging, this is going to be the final result. Cities, okay, this city population will drop till it reach 15,000. And the suburban will increase till it reach 25,000. Assuming that the amount of population remains the same. That's a total of 40,000. We started this model with 30,000 for cities and 10,000 for suburbans. And due to this change, you will end up having suburbans with cities with 15,000 and suburbans will carry 25%. Okay, or 25,000. Are you with me? Any questions? This is really a very important problem. Of course, Mr. Ahmed, it's not going to come to you as you saw it in this model. Because in this model, we already started to evaluate. First of all, we tried to translate the model into the magic sphere. So that's trying to have something explained into numbers. So it's a mathematical modeling. Step number 2, we went through finding eigenvalues and the corresponding eigenvectors and get the diagonalization. Step after that, we started to apply the steady state shape in order to speculate in the future. So it's really a very nice problem. معايا مستر حازم؟ خد بالك بتاع التكليف ان شاء الله. بص ايه بص خد بالك عامل ايه؟ اوكي. في حته كمان برضه exercises of dynamical systems. Before I forget, inshallah on next Thursday, which is going to be, I believe it's 27 or 26, something like this, you will have on Thursday, okay, a meeting with Dr.Omar, and he will go with you with the remaining Python programs just to try them on your laptop. So bring your laptops with you, not this Thursday, not tomorrow, but the Thursday after. You have a week. Please tell your companions. This is very, very important to attend. Okay, it's going to be the last section. Okay. Okay, let's go to this problem, and that's an amazing problem also. Okay, Mr. Hassan, do you think that the mathematical model of the model of movement in population between a city and suburban, this was the dynamical systems? I can apply it on plenty of situations. Hassan, look at this problem and let us think together. He is telling you, consider that after each year, بعد كل سنة, 20% of the clients from firm A moved to firm B. So, once more, after each year, بعد كل سنة لازم تشتغل مع الشركة تنصدم ماشي من القرف بتاعته، فيروحوا بقى 20% من الكلاينتس شتمنهم ورايحين لفين؟ الشركة. يعني زي الموبينيل مثلا واتصالات. تشتم موبينيل وتروح لاتصالات، تروح لاتصالات تشتم اتصالات وترجع للموبينيل. كده يعني. I consider after each year, 20% of the clients of firm A moved to firm B. While 30% of clients from firm B moved into A. معايا يا مستر احمد؟ يبقى إذا بكل بساطة in order to think about what's happening, all I have to do, I will have to make a sketch. So if this problem comes to you in an exam solving, you will have to think. So I will do this exactly, I want you to do exactly like what I'm going to do. So this is company A, that's company A, and that's company B. So each year you have 20% migration from the firm A into firm B. This is going to be 20%. And from B, 30% of clients will move to A. So this is 30%. By the idea, Mr. Rahman, I can complete the model. This is 20% of the clients moving from A to B. So you will have 80% of the clients remaining with A. And for B, if 30% moves to A, then you will have 70% of the clients remaining with the same company. Okay. Let XIT with I, A, and B be the number of clients, which means X1, A, X2, B. Do you read me? This is why he wrote Xi and time. So if I is equal to 1, we are talking about the A company. If I is equal to 2, we are talking about B. Okay? Okay, be the number of clients of firm I in year T. And the X of T represents the number of clients. Assume that in the first year, year 0, So this is the initial values, like the 30 and 10. Okay? At year 0, firm B has 70 of the 100 clients. And firm number B, it has overall 70 of 100 clients. That means firm A had 30 clients. Okay? Boom, boom, boom. 100 in the market. The total number of clients is constant. Like the total number of population is constant. 30 and 10 and will remain. Okay? Find the matrix A. To write the expression xt plus 1 equal to axt. Exactly like what we did in the movement between cities and suburbs. So, once more, I will go and he asks you to generalize A to find the case when t is equal to infinity. And he wants you to show that for any initial distribution clients, xt will end up if t tends to infinity, 60 to 40 as values. Which means we will do exactly what we did in the movements between the companies and stocks. So the first step is to form our model. And this is exactly what we did. This is company A, and that's company B. I have 20% from company A moving to company B, and 30% moving back. So I have a 70% of the total and the 80%. Now I can write the matrix. The matrix, if you remember, A to A to B, am I right? B to A, B to B. Now the matrix will be very helpful for you. Now, simply all I have to do is to use what I told you about. So from A, it's going to be 0.8% times x1 of t plus 0.30 times x2 of t. Here we go. 0.8 xa of t or x1 of t, 0.3 xb and t or xb2 and t. And for the second row, B is going to be 0.2, which are the movement from A to B, plus the people in B, which is 17%. Now I can put them in a matrix, okay, which is simply going to be 0.8, 0.3, 0.2, 0.7, as you can see. I can analyze it to get the eigenvalues and the eigenvectors. Can you help me out with this? The eigenvalues? Huh?
Yes.
0.8 plus 0.2?
1.
0.3 plus 0.7?
1.
So 1 is one of the eigenvalues. How to get the remaining of the eigenvalues?
0.8 to 0.
Get the sum of the trace, which is 0.8 plus 0.7, 1.5. So the second value of lambda is going to be 0.5. This is exactly what we did. Okay? So once more for the diagonalization, this is the matrix that we will be dealing with. I will try to solve the system. I've here wrote the steps for you if I want to not to evaluate using the column issue. I will be ended up having lambda 1 is equal to 1 and lambda 2 is equal to 2.5. Exactly like what we did. Now I will start to get the corresponding eigenvalues. I've already wrote this for you. Sum of each column is equal to 1, so 1 is one of the eigenvalues. And the trace is 1.5. So 0.5 is another eigenvalue for this problem. Of course, after this, I will go to get the eigenvectors. How to get the eigenvectors? I will use exactly the same model. Okay? So it's going to be the matrix. This is lambda is equal to 1, and then I will use lambda is equal to 2.5. Step by step. Here is the matrix. Subtracting 1 from the elements of the pencil and the apple and ahmad. So it's going to be minus 0.2, 0.3, 0.2, 0.3 with negative. That's what we have. If we multiply, if we add the first row to the last row, it's going to be zeros. Now I can divide on 0.2 and get a relation connecting V1 and V2. Here we go. That's the relation connecting V1 and V2. Now I have the first vector, which is going to be 1.5 and 1. Okay? That's the first vector, 1.5 and 1. Okay? So exactly in a similar manner, I will use lambda 2 equal to 0.5. But in this time, I will replace this is 0.5 and that's 0.5. Already doing this will lead to this system, which is going to come up to this form. Okay, divide on 0.3 in order to have this one, and you will be able to eliminate the second row in the simple manner. And in this way, you will have V1 is equal to negative over V2, so the numbers are going to be negative 1 and 1. Now I have the B matrix. The first column in it is going to be 1.5, 1.5 and 1. The second column is going to be negative 1 and 1. And the diagonal matrix will be 1 and 0.5. First eigenvalue, second eigenvalue. Now I can put them in this form. A is equal to P, D, P minus 1. I'm not talking about cities anymore. I'm talking about two companies. All right? Okay, once more, if I want to get t tends to infinity, all I have to do is to substitute in this matrix. This is 1 and that's 0.5. 0.5 to the power of t is going to end up having 0. That's after taking the limit. So I will multiply this guy in b and the b minus 1. This is going to be the result as I told you, which is going to be 0.6, 0.6, 0.4 and 0.4. If you multiply by 30 and 70, from where 30 and 70? Because we started with the multiplication of the first, the second company having 70 clients out of 100. You will have 60 and 40, which is exactly the requirements of this problem. Now, Mr. Hamid, probably in your final exam, you will face one of these problems, and he will ask you about the questions, get the eigenvalue, is it diagonalizable, what's going to be the case, and so on. Look to this, okay, just in a second. Look to this problem too. That's another problem containing another issue or another story. He's telling you that consider a car rental company. Consider a car rental company. So it's a company renting cars. With 700 cars. الشركة دي عندها كام عربية؟ 700 cars. And the parking locations 1 and 2, 700 cars دول بتركنهم في 2 parking. That's a parking, and behind the buildings there is another parking between both. Okay. Cars can be rented in either location. يعني العربيات دايما عربيات الرنتال مش عارف اذا كانت انت عندك الخلفيه دي ولا لا، بس دايما عربيات الرنتال بتاع الشركات الكبيره يعني زي بادجت زي هيرتز زي وات ايفر زي plenty of big renting companies. I can rent from Cairo and drop off the car in Alexandria and vice versa, or take the car from Cairo and drop it in Aswan. Okay, in any office regarding this car. This is what he is explaining for you. So he is explaining that he has a company with 700 cars and 2 parking locations. Locations free. Cars can be rented from either location and deposited in the other location. Consider the relationship x t z1 t plus 1 is equal to ax sub t. Xt is x12, x2 sub t for the second parking at any time. Okay, he is giving you the A matrix with the percentages. What's T over 4 stand for? What's T over 4 over 5 stand for? رقم ده عبارة عن ايه؟
2 over 5.
ايه؟ the A. The cars that will be rented from the first parking and will be deposited in the first parking. طيب A 4 over 5? The cars who are rented from the second parking but will be deposited in the first parking. معايا محمد؟ طبعا ممكن يسألك على أي رقم من دول أو يديك alternatives وأنت تختار إذا كان multiple choice question. فاهمني؟ Did you see the matrix A B B A B B? It's really very helpful. Okay, complete the sentence in each month. شو بقى the sentences؟ نديك completion drag and drop. بيقول complete the sentence in each month. What's the percentage of cars rented in location 1? ايه عدد السيارات اللي rented in the first location؟ عدد السيارات اللي rented in the first location او اللي موجودين في first parking simply is going to be the sum of the two values of 0.2 plus 0.4, which is going to come up 2.6. Okay, here we go. This is the distribution. That's the 40%, 60%, 20%, 80% according to this distribution. ما الارقام دي انا جبتها منين يا حسن؟ الارقام دي انا جبتها منين؟ من دي بالعكس. From A to A 40% اهي 40%. فاهمني؟ From B to A 60%. انا اسف 80%. لذلك ده 80%. معايا يا شباب؟ بعدين ده 35 او 3 over 5 هو 60%. بس ده B to A فاهم؟ B to A I'm sorry A to B لذلك from A to B 60% طبعا هيديلك 20%. Some of these two guys must be 1 some of these two guys is equal to 1. طبعا مجرد انك تعمل ده هتقدر على طول انك تكمبليت ده ب 60% ده 80%. In a similar manner هو بيسألك على diagonalization يبقى انا هلاحظ برضو ان الفاليوز دول لو انا جمعتهم vertical it's gonna come up to 1 وده 1 يعني اذا ده معناه ان الايجن فاليو بتاعتك هتطلع بتساوي 1. انا حليت طبعا هنا واحده ب 1 ولما تجمع 2 over 5 1 over 5 is gonna be 3 over 5 so the second eigen value will be negative 4 over 5 negative 2 over 5 يعني I'm sorry negative 0.4 يعني. الستيب اللي بعديه I will try to get the eigen vectors in a similar manner بالظبط زي ما انا عملت قبل كده. هيطلع لي الريليشن ان الفيرست فيكتور 4 over 3 or 1. على فكره انا ممكن مش هحط دي ب 3 انا كنت ممكن لو انا خدت ده ب 3 ده هيبقى 4 ده يبقى 4 و 3 اوكي بس يعني ينفع كده وينفع كده. In a similar manner that's لو ده 2 وبالتالي هيطلع منه second eigen vector. خلاص انا دلوقتي عارف دي البي وطبعا ده 1 negative 2 over 5. دلوقتي اقدر to speculate how it's gonna be after second year or after certain number of years. This is after the first movement. These are the values multiplied each other. Of course, that's the inverse of this matrix. Okay. Then you also that's the inverse of that matrix. If you try to get the inverse. Okay, so you will start with 700 cars. If you make the substitution, you will end up having 400 and 300. Okay, that's the distribution of the cars after the steady state or after a period of time. ماشي. Thank you very much. It was supposed to be our last lecture, but as I told you, we have another chapter added on us. It's about the quadratics, and I will finish it, inshallah, on Monday. Please try to attempt on Monday. It's very, very important to attempt. Okay? Now, if you remember, or if you remark, you didn't attend, some of you didn't attend in the previous session. So he is came today, has no clue about what's an eigenvalue and what eigenvector. While Muhammad attended at least the last session. So really he knows what's all about. It's a huge difference if you didn't attend. Thank you very much. I will see you next time, inshallah. I think I sent you all the PDFs of this lecture, either from lesson or from my version. Am I right? I sent it to you on WhatsApp.